Hey guys, this is part 3 of the video on decomposing rational expressions, trying to find the antiderivative of a rational. What if, in the previous two, we always had like something that was quadratic, so it broke down into two factors. What if something has three partial fractions or more? How are we going to approach it? And it is, in essence, just an expanded view of what we've done in parts 1 and 2. The first key thing is to set up for every linear factor of the denominator. We need x to the power of 1 factors under each of our fractions. So if we need three fractions for like how x squared minus 4 factors into x plus 2x minus 2, there's two of our fractions, a over b over. That third factor, because it's there, x over c over x minus 1, that still means that we have a plus b plus c plus, and it equals the original equation. So we need to really know what a, b, and c are in order to get the answer we're looking for. So in this case, since x squared minus 4 times x minus 1 is the common denominator, what's missing from a is x squared times x minus 1 times x minus 2. What's missing from the b term in the middle fraction is what's missing from its denominator in order to have the common denominator, so we're going to multiply it in. And the same thing with c. When we're all done, we get this expression that equals 6x squared minus 8x minus 4. So expanding everything out, running out of room on my paper and trying to make sure it all still looks linear with its flow, we wind up with an expression a times x squared minus 3x plus 2 plus b times x squared plus 1x minus 2 plus c times x squared minus 4. And we look for things that we can group. Because there's a 6x squared, that means a plus b plus c, that was in all three of them, equals 6. Because there is a linear coefficient, the part in the middle, that would be the negative 8. Negative 3a plus b equals negative 8. And then last of all, 2a minus 2b minus 4c, that whole expression doesn't have an x, doesn't have an x squared, it's the constant, it equals negative 4. We're setting up a system of 3 equations, 3 unknowns, and solving it. Good luck. You could use elimination, you could use substitution. Actually, row reduce echelon format, mentioned it in the previous 2 parts. You learn about it in linear algebra as it's a matrix process, a way to simplify a matrix and get down to a 1, 0, 0, whatever. I'll stop talking about it. It's amazing. It's really easy to figure out after you've seen it a couple of times and you're like, this is just what I do. Very algorithmic. It gives us a chance to figure out our answer here. I guess I'm kind of just allowing you to see my own thought process. I thought, I'm going to do some elimination method. And then I get to a point where I'm just like, brain freeze. What do I do? And so I jumped online and went to the internet and share with you kind of just a little montage of the work that I did right there. What is going? Okay. 3010. 310. So I tried elimination method. My mind went blah. I don't like it. 3, 2, 306. So I'm trying elimination method of the other methods, and I just thought, you know what? I'm having a real struggle with this one. Let me bring out some math magic. Thanks, Wolfram Alpha. I just wanted to get the answer. I got a equals 3, b equals 1, c equals 2. So those can go into my equations as 3 over x plus 2 and, 1 over x minus 2 and 2 over x minus 1. Each of those are equal to the original expression 6x squared minus 8x plus or minus 4 over. Because we're able to separate that rather complex rational expression into 3 simpler linear denominators, we're able to do the integral real quick. It seems there's a pattern here, most of these problems result in some natural log of the absolute value of the denominator. As in, like, that's the shortcut from Calc 2 that you need to know about. The antiderivative of 1 over x is natural log of the absolute value of x. So what happens when you have a coefficient, or no, a constant in there? Ooh, a coefficient, that'd be a good one too. None of these had a coefficient. Room for growth, room for extension. There is no part 4 to this video. You're welcome. From this point on, I'm just using logarithm properties. Point being, as what I was saying, is that what if it was 2x plus 2? What would you do? I think you can figure it out. Properties of logarithms allow me to do a lot of major compressing, and there it is, plus c, the antiderivative of 6x squared minus 8x minus 4 over x squared minus 4 times the quantity x minus 1. You're welcome. If you watched all 3 parts, you're amazing. If this is your first chance to see the antidifferentiation by partial fractions process, I encourage you to go back and watch parts 1 and 2. Not for the views, mainly for the understanding. Although, you know, the views are nice. But the point is that I want to make sure you understand that. So if you're struggling with this at all, send me a message, drop me a comment, let me know if I can help out in any way. Thank you for watching this video. Thanks for doing some math with me. See you in the next video.